In this video, I'm just going to introduce you to the concept of a logarithm. We're not going to go into a lot of depth, but just to give you a basic idea of what the notation means and what it tells you. So let's start by looking at exponents, because exponents and logarithms are intimately connected. Let's look. 10 squared is equal to 100. What this says is if I have a base of 10 and I raise it to an exponent of 2, I get 100. And hopefully you realize that means I take two factors of 10 times each other, and that gives me 100. Now let me write a log expression that goes with this. Log base 10 of 100 equals 2. This tells me if I have a base of 10, what exponent do I have to put on 10 to get 100? What exponent do I put on this base, 10, to get this number, 100? So the other side of a log, when I say log base 10 of 100 equals something, that something is an exponent. So 10 raised to the second power equals 100. The two most common log bases are log base 10 and log base e. So if you see just log of 100, that means automatically base 10. If you see the word log and nothing written next to it, we're talking about base 10. So let's look at a couple other examples of log base 10. So we might say log of 1,000. Well, I'm saying what exponent do I put on a base of 10 to get 1,000? Well, I have to do 10 raised to what? So this is what I'm asking myself. 10 raised to what power equals 1,000? So the answer is 3. Log of 1,000 equals 3. I could say log of 10,000 equals 4. Log of 100,000 equals 5. But let's go smaller here. What about log of 10? Log base 10 of 10. What exponent do I put on 10 to get 10? 1. 10 to what power equals 10? That's what I'm asking myself. What about this one? Log of 1 equals, that's tough. I'm saying 10 to the what power equals 1? Well, this is one where you have to remember your exponent rules. Anything raised to the 0 power gives you 1, except for this. 0 to the 0 is undefined. 0 to the 0 is undefined, so you can't do that. What if I did log, and that doesn't mean 0 degrees, it means 0 to the 0 power here, so be careful of that. Log of 1/10. So I'm saying 10 to what power is equal to 1/10? Hopefully you recognize that is -1. So when I have a number less than 1 inside my log, I'm going to get a negative exponent. Okay, so there's just some examples. What about, can I do log of a negative number? Log of -10. So 10 to what power gives me -10? 10 to what power gives me -10? So if I raise it to a negative exponent, does that make the number negative? No, it just means I take the reciprocal. So 10 to the -2 would be 1 over 10 to the squared. That's still positive. There's no way to get a negative number. So this is undefined. It's an actual it's a non-real answer. Okay, so I can't take the log of a negative number. I also can't take the log of 0. I kind of like to move this thing now. Wonder if I can kind of grab it all and just move it out of the way. There we go. Log of 0 equals, well, I'm saying 10 to what power equals 0? Is there any exponent that I can put on 10 to get 0? No, there isn't. That's also undefined. Okay, so I can take the log of a fractional number, a number less than 1, but I cannot take the log of a negative number, cannot take the log of 0. Okay, so this is all log base 10. Now let's take a look at the other commonly used log. And actually this is called the common log, log base 10. But let's look at log base e. Log base e, which is, so log base e of, I don't know, 4, for example. Okay? So I'm saying e to what power gives me 4? Now this is something I would have to do on the calculator, and you will, and so I can't give you any concrete examples of this really, but e is about 2.7 something, so it's going to be, if I made the number 2, it would be too big, so it's going to be somewhere between 1 and 2, because e to the first would equal e, and that would be about 2.71828. E squared would be 2.71828 squared. So I know that whatever number, and that's going to be bigger than 4, right? So I know that this answer has to be between 1 and 2. So I'll just leave it there for right now, just to get you kind of thinking about this. But what I wanted to tell you is when you use this terminology, natural log of 4, that means the same thing as log base e of 4. So when you see natural log, that's just an abbreviation for log base e. That's called natural log. The other thing I wanted to tell you about logs is how logs are related to exponential functions. So we have an exponential function. So let's say we have let's start with our exponential function. Let's say we have the function f of x equals 2 to the x. So I'm putting exponents in for x, and I'm getting numbers out for y. So I'm putting in like -2, -1, 0, 1, and 2. And I'm getting, for y, I'm getting 2 to the -2 would be 1 over 2 squared, which would be 1/4. 1 over 2, which is 1/2. 2 to the 0 is 1. 2 to the first is 2, and 2 squared is 4. So I'm getting points like -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8, etc. Okay, and when I graph that, I get a graph that looks like this. Now, if I do log base 2 of x equals, I'm saying I'm putting in numbers that are powers of 2, and I'm finding their exponents. So I'm saying, for example, if x were 8, let me rewrite this, sorry. Let me write this as f of x is equal to log base 2 of x. So what I'm saying is my x value is a number, and the y value, or the f of x value, is the exponent. 2 to what exponent gives me x? 2 to what exponent gives me x? So let me rewrite this as y equals log base 2 of x. And what I'm really saying is 2 to the y power equals x. So this is going to be all the opposites of the values I got previously. So if x is, for example, 8, then y is going to be 3. Let me extend my page a little. If x is 4, y is going to be 2. If x is 2, y is going to be 1. If x is 1, y is going to be 0. If x is 1/2, y will be -1. So notice that all the points just switch places. So when I graph this, I get a graph that looks like this instead. Notice that all of my x values are going to be positive, because all of my x values are going to be powers of 2. All of my y values could be positive or negative, because they're the exponents that I put on 2 to get these numbers here. So this is, notice that these graphs kind of undo each other. They are inverses of each other, and we'll talk more about this. But this is the basic shape of a log graph. I didn't take the time to plot the points, because you could plot those, but this is the basic shape of a graph for a log graph, and compare that to an exponential graph. This one has the x-axis as an asymptote. This one has the y-axis as an asymptote. Okay, there's enough for getting you started with logs.